and welcome to another installment of the Old Gazer YouTube channel. My name is Larry. This channel is all about providing practical advice, practical suggestions, giving some practical information to beginning amateur astronomers or inexperienced amateur astronomers who are trying to work their way through the steep learning curve that kind of comes with the territory when you begin to pursue this very wonderful hobby. So that's what it's all about. Hopefully you'll find something of value or use in here. With that said, let's just get right into the subject matter of this video. I want to talk about something that is a very unfortunate thing, a very unfortunate aspect of amateur astronomy. Something that can be a real impediment to the enjoyment of the hobby, something that's just a bane of all astronomers everywhere. And the thing I'm talking about is something called light pollution. So what is light pollution? Well, light pollution refers to the lightening or brightening of the night sky by sources of artificial light. Street lights, city lights, security lights, anything that provides artificial light at night can lighten the night sky and keep it from being dark enough for us to really enjoy and make it very difficult for us to see many of the dimmer and fainter objects that we would very much like to view or image in the night sky. I read recently that only about 83% of the world's population has never seen the Milky Way because of light pollution. 83% of those living today. I also read that about 1/4 of the Earth's surface is subject to continual sky glow, which is the lightening of the sky caused by lights from cities or towns or other major sources of artificial light. Very sad circumstance. Now, light pollution is not just a problem for astronomers, by the way. Studies have shown that it has an adverse effect on ecosystems. It can even negatively impact the health of people. So, it's tempting to refer to this thing as an evil that we have to contend with. But, the world is becoming a 24/7 place. Life is 24/7 now. Everything has to be lighted up in order for that to take place. Unfortunately, it's just going to get worse, and there's not a whole lot we can do about it. But it is a very unfortunate thing that we have to deal with. I don't know how many of you have ever seen truly dark night skies. If you have, you know how breathtaking and glorious it can be. I have, on some occasions, seen skies like that. The most vivid memory that I have of seeing a really dark, spectacular night sky harkens all the way back to the Jurassic Age when I was in college in the late 60s and early 70s. Yeah, that long ago. I took a survey course in astronomy, a sort of astronomy 101, if you will. And one of the things that we did in that class was learn a little bit about astrophotography, which of course is taking pictures of things in the night sky. We were given an assignment during that course to take a 35mm camera and a tripod and go out to a remote location and take some pictures of constellations and take some pictures of star trails and that kind of thing. And I do remember doing that, but my most vivid memory of that night is how spectacular that night sky was. We were out in a very remote location, and back in the 60s and 70s, there were a lot more dark sky locations than there are now. But I had trouble finishing the assignment that we were being given, that we had been given, because I just couldn't take my eyes off of that night sky. I hate to use trite and overworked expressions here, but it was the heavens were literally spangled with stars that night. It was truly like somebody had taken a handful of diamonds and just cast them across a sheet of black velvet. You've heard these things said before. But none of that really does justice to the beauty of the night sky when you can see it under dark conditions, which I did that night, and that's something that I'll never forget. Hope some of you have had the opportunity to see the skies like that as well. If you haven't, then maybe you'll get the opportunity to get to a really dark sky location at some point along the way and experience that for yourself. Of course, we can't, most of us don't see skies like that anymore, and that is a crying shame. How bad is the light pollution where you are? Well, of course, you can subjectively determine that by just walking out at night and looking up at the sky. If you're in a heavily light polluted area, you won't be able to see anything but just a very few of the brightest objects in the sky. If you're in a very pristine location, of which there's almost none left, but you know, if you're in a dark sky location, you'll see a much better view of the night sky. And then there's everything in between. So you know already, you know, about what the condition of the or the status of light pollution is where you live. But there's a way to objectively quantify that. In 2001, a man by the name of John Bortle came up with a scale that attempts to measure the relative amount of light pollution at various locations around the world. Now, not surprisingly, that's called the Bortle Scale. It ranges from a zone 1, which is pristine dark sky locations, all the way up to Bortle 9, which is those locations typically in inner city areas that have the worst light pollution, and of course with everything in between. I want to share with you a resource, an app or a website, depending on how you're viewing this, that can be very, very helpful in helping you understand the level of light pollution where you are and in helping you find other places where the viewing might be better. Now, this resource is called lightpollutionmap.info. lightpollutionmap.info. And what I'd like to do is to pull that up on my computer screen and just take a few minutes to look at that and show you how that can be useful in helping you understand this whole sorry issue of light pollution. So let's just do that right now, and then we'll come back and discuss it some more. Okay, I have lightpollutionmap.info on my computer screen here now, and this is a map, of course, of the United States, and as you can see, it is color-coded. The heaviest light pollution are in the white and red, purple areas, and then it progresses down through yellow and various shades of green and blue, and then into light gray and all the way down to dark gray, which would be the least light polluted skies. It's kind of depressing to look at that and see how much light pollution there is in the eastern half of the United States. Very, very few dark sky locations remaining there. In the western part of the country, there are numerous dark sky locations, most of which are in desert or mountainous regions. So that's just an idea of what light pollution looks like in the United States. I'm going to put my own local coordinates in here. I'm at about latitude 36 degrees north, and I'm at longitude about 79. So I'm going to put that in there, and it will zoom into my location, and there it is. And as you can see, I am in a class 5 zone, a Bortle zone of class 5. I'm going to zoom out a little bit and down so that you can see that better. That's the information that's included here for my specific location, which is, as you can see, a Bortle class 5, and it gives you some other indications of brightness and of the overall degree of light pollution that exists here. As you can see, just to my southeast are the very heavily polluted skies of the metropolitan Raleigh-Durham, North Carolina area. So I'm in class 5 skies, unfortunately closer to class 6 skies than I am to class 4, so not very good here. Now, one of the interesting things about this map, if I scroll down here, I can come up to this region right here, and I'm going to zoom in a little bit. This happens to be a state park in Virginia, Staunton River State Park, and if I go right here, I just come down a little bit more, you can see that location right there, which is in Staunton River State Park, is class 3. That's about roughly an hour and a half drive from where I live, so it's a 3-hour round trip for me to get there, but that is the nearest thing that approximates dark skies that's within any realistic traveling condition of where I live. So your situation might be worse, it might be better, but you can use this tool, lightpollutionmap.info, to find out what your Bortle zone is, and to perhaps find areas somewhere that you could, within a reasonable traveling distance, where you could go to find darker skies. So just wanted to give you a look at that, and I highly recommend this app. It's very, very good and will help you sort of work your way through this whole sorry issue of light pollution. Okay, I hope that was beneficial for you. I highly recommend that resource, lightpollutionmap.info, and you can see how it works and how to use it, and I just thought that might be worthwhile to take a look at that. So that gives you an idea about how to quantify how bad the light pollution is where you are, and we'll give you the opportunity to seek out some other locations that you might at least occasionally be able to go to do some better viewing. So let's talk about, just for a moment now, the two major kinds of light pollution. Now, I think there are more classifications of light pollution than just these two, but these will suffice for right now. The first type is something we've already alluded to, and that's called sky glow. Sky glow is what you see when you look towards a large metropolitan area or a big town, and you see that luminous dome of light over that city or over that town that is lightening the night sky and brightening the night sky. I happen to live in an area here where I have sizable towns located pretty much all around my perimeter here, so no matter which direction I look along the horizon, I'm going to see a significant amount of sky glow, especially to the south and southeast where the metropolitan area is. Now, if you live within a Bortle 8 or 9 zone, you're living within that dome of luminance. So no matter which direction you look in the sky, you're going to see light polluted skies. The skies are not going to be dark anywhere. They're just going to be various shades of gray that are going to make everything that you might want to see dim and possibly not even visible, except for a few of the very brightest objects in the sky. So that's one type of light pollution, sky glow. A second type of common light pollution is called localized light pollution, and that comes from things that are near your vicinity, near the area where you're viewing or imaging objects, which cast light directly onto your viewing area. Things like street lights that are close to your viewing area. Perhaps you've got an annoying neighbor that likes to burn a security light, let's say a floodlight, all night long, and that floodlight happens to be pointed in the general direction of your backyard. Things like that. Some people refer to those kinds of light pollution as trespass light pollution because they're localized sources of artificial light that are sort of trespassing on your viewing or area and causing problems. But localized or trespass light pollution, you take your pick there. Very serious aspect of light pollution. And you deal with these two things in different ways, which we'll talk about in just a moment. So now let me just give you my own personal situation by way of example of how light pollution can interfere with or be an impediment to enjoying the hobby of amateur astronomy. I live in a Bortle 5 zone, as you've already seen, but I live much closer to a Bortle 6 zone than I do a Bortle 4 zone. So I'm sort of in that transition period between Bortle 6 and Bortle 5. Could be worse, but it certainly could be a lot better. And those of you who live in Bortle 8 or 9 zones are probably saying, what's he complaining about? But let me tell you what it's like to try to view dim objects, deep sky objects from my Bortle 5-6 zone where I live. First of all, I'm supposed to be able to see things up to magnitude 6 or so with my unaided eye. I don't think I can really see things of magnitude 6. I have to come back to 5, 5.5 to really be able to say that I can actually see those things with my unaided eye. Now maybe I'm just getting old and my eyes are not what they used to be. Maybe a younger person with better eyesight could see magnitude 6 objects from my skies, but I can't. Another indication of how bad it is here is that I absolutely cannot see the Milky Way from my Bortle 5-6 skies. Now, theoretically, in a Bortle 5 zone, you should be able to see at least a hint of the Milky Way along the horizon, and in those parts of it that are higher in the sky, you can get a better glimpse, just a hint of the Milky Way. I must tell you that I absolutely cannot see the Milky Way at all here in the Bortle zone where I live. Believe you me, I have searched for it and searched for it and searched for it, and I simply cannot see it. I have an 8-inch telescope here, this 8-inch Schmidt-Cassegrainian right here. Now, an 8-inch telescope has pretty decent light gathering capability. This telescope can gather over 800 times more light than the pupil of my eye can. And you would think that even when you're looking at one of these deep sky objects out there, even in a Bortle 5 sky, that ought to collect enough light to give you some decent views. And it does for some of the brighter deep sky objects. But most of the deep sky objects only show up in this telescope, through this telescope, as gray, cloudy, or fuzzy masses. And it takes some special effort to do some things to mitigate that light pollution a little bit, to make those views come in a little bit better, which we'll talk about here in a minute. But that's how I'm impacted here by light pollution. Not a fun thing, not a good thing. So the question then becomes, what can we do about light pollution? Are there some things that we can do to mitigate light pollution and be able to enjoy our hobby more? The answer to that is yes. Now, far and away, the best thing you can do is to go to a place where the skies are darker and do your viewing and imaging there. Find darker skies. If you're in a Bortle 8 or Bortle 9 zone, at least try to get out to Bortle 6 skies or something if you can. I have, as you've seen in the illustration that we gave you with the light pollution map, I live about an hour and a half away from some Bortle 3 skies, which is pretty good skies, at least by today's standards. But unfortunately, it's a 3-hour round trip for me to get there and back. There's logistics involved. I have to load all of my equipment up and get it there and then set it up and then break it down and bring it back. You might have to worry about getting permission to view in these darker skies. You might have to be concerned about whether or not it's a safe area. A lot of things can come up, and it's just not convenient and not even possible on a routine or regular basis to get to those darker skies to view your imaging or your viewing. But we all owe it to ourselves, at least occasionally, to get to a darker sky location just to see how much better the viewing is there, and to get that sense of, a better sense of what the skies at night are really supposed to look like. It'll be well worth the effort, and you'll be glad that you made that effort, at least from time to time as opportunity allows. But in real terms, in the real world, I realize we're going to be doing most of our viewing right in these nasty polluted skies where we live, which are worse for some than others, but that's something that we're all going to have to deal with, most all of us anyway. So are there some things that we can do in light polluted skies rather than having to make a trip to darker skies? Are there things that we can do to mitigate light polluted skies? There are some things that will help, I'll put it that way. And let's talk about what a few of those things are. First of all, you should attempt to establish and maintain good night vision. Now, what do I mean by that? What is night vision? When you go from a lighted area into a dark area, your eyes will begin to adapt to the darkness. And over a period of about 30 to 45 minutes, roughly somewhere in that range, your eyes will have adapted to the dark conditions, and you'll be able to see much better than when you first went out from the light into that dark area. And if you can establish and maintain good night vision, you'll be able to see more things, and you'll be able to see them better, both with your unaided eye and by looking through a telescope. Now, let me just admit here that it is extremely difficult to maintain good night vision, especially if there are a lot of localized sources of light pollution in the area where you're observing. All it takes to spoil your night vision is a look at a lighted cell phone screen, or perhaps an inadvertent glance towards a street light, or maybe a car is coming up the road in the wrong direction and the headlights shine on your eyes. Your night vision is gone and it has to be reestablished then. So very difficult to maintain night vision through a night of viewing, but you owe it to yourself to make every attempt to do so, because it will definitely improve the things you'll be able to see, and the quality of that viewing experience will be. Now, if you have to use a light when you're outside, use a red light rather than a white light. That will have much less impact on your night vision. Some astronomers wear headbands that have a red light mounted right here on the forehead. Very, very nice tool. You know, the light goes where your head moves. Just an excellent thing to use. I have a red flashlight. I have another couple of sources of red lights. Make sure that when you go out, you've got a source of red light that you can turn on when you need light. Don't use white lights. Use red lights instead. So, try to establish and maintain good night vision. When you need light, use a red light rather than white light. Second thing that you can do, and this is rather obvious, is that if there's anything you can do to block any sources of localized light pollution from your telescope or from you, by all means do that. Perhaps you can get around the corner of a house or a garage or a tool shed or behind the trunk of a tree, or pull back a little further within your apartment balcony or wherever you might be. Do anything and everything you can to try to block those sources of localized light pollution from your eyes and from the optics of your telescope. And that will help a lot. Use a dew shield. Now, of course, the primary purpose of a dew shield is to shield the optics of your telescope from accumulating dew, but they have a nice side benefit as well. I think you can see that this could be very helpful in helping to block off sources of localized light pollution and prevent them from impinging directly on the optics of your telescope. A very nice tool, a very handy one to use. I never go out to view deep sky objects without my dew shield in place on the telescope. So do that. Use something that you can wrap around your head, drop down over the eyepiece of your telescope or your camera to block any stray light from coming in and impinging upon your eyes, impinging upon your optics or your eyepiece or whatever. And that will help you to see better if you can block out those sources of light in that way. Now, I understand that there are things called astronomers' vests or astronomy hoods that it's a garment that you put on. It's a vest usually. It has a hood that comes down and covers your eyes, your face, pardon me, covers your eyepiece or your camera or whatever you're using. Helps to block out all that stray light from getting in there and fouling things up. And now, these vests, I understand, have pockets in them, which are very handy for storing, various pieces of equipment while you're out there doing your viewing or imaging. I understand these things can be quite pricey, so just get a hoodie. Try to get one with a hood large enough to come down over your eyes and your eyepiece and your camera or whatever to block out all that stray light and keep that out of there. You can wear a hoodie even if it's warm outside. Better to be a little uncomfortable and use every tool at your disposal in the war against light pollution. So use a hoodie. If you don't have that or don't want to do that and don't want to be uncomfortable, put a towel over your head and your eyepiece or your camera, or even a dark t-shirt, and use those to block this stray light from coming in and keep that out. Now, you might think, well, my neighbor's going to look out the window over there and see me out in my driveway all humped over here with a t-shirt or something draped over my head, and they're going to think, what are they going to think about that? Well, let's face facts here. Us amateur astronomers are all nerds and geeks. And anybody that says otherwise is just a lying liar telling lies. I mean, I'm a geek, you're a geek. All amateur astronomers have have one thing in common. We're nerds and we're geeks. We are. And so your neighbor's going to look out there and he's going to see you all bent over with this thing draped over your head or something. He's not going to give it a second thought. They're just going to presume that that's just another display of geekery going on, nothing out of the ordinary, and that'll be that. Now, all kidding aside, use something, whether it's an astronomy vest or hood, or a hoodie, or a towel, or a dark t-shirt. Drape something over your eyes, your head, your eyepiece, your camera, or whatever, to help block out stray light from coming in and impacting your eye or the optics of your telescope or your imaging system. Just a very sort of common sense thing there. Try to view objects when you can, when they're higher in the sky as opposed to lower in the sky. Along the horizon, lower in the sky is where sky pollution is going to be worse. And so if you can look through less atmosphere and away from those sources of sky glow, you should be able to see more and see it better. Just common sense there as well. Light pollution filters are designed to try to filter out some of the wavelengths of light that emanate from these sources of light pollution. For example, they'll attempt to filter out the wavelengths of light associated with street lights and other common forms of light pollution. There are some more sophisticated filters they'll do even more things. There's basically two types of these filters. There are broadband filters, which basically let all the light through, most of the light through, except for some of the wavelengths associated with street lights, as we've said. They can also be somewhat effective in dealing with moon glow, which of course is the washing out of the sky caused by a moon that's in the sky and shining, especially if it's full or nearly full. This can be of some help also in that. Now, the narrowband filters are used primarily by serious astrophotographers, and they will literally filter out all light except the specific wavelengths that are emanating from these emission nebulae that they're trying to photograph. And that will give them much more detail and very colorful images of these nebulae and so forth. I'm not a serious astrophotographer. I've never used any of those narrowband filters, but I do use this broadband filter to try to help a little bit in improving contrast, helping to block out a little bit of the sky glow and moon glow, and I do use that. These filters, you can get them that fit in your DSLR cameras right in front of the sensor. You can get them that fit in various places. I use one that just screws into the base of my eyepiece like that. And now I'm all filtered up and ready to go. these filters get mixed reviews. Let me just, in all fairness, say that. Some say that they are quite helpful. Some say that they're a little bit helpful. Some say that they can't really see any difference whether there's a filter in there or not. Some say it even makes things worse because they darken everything in the sky, including the object you're trying to view. So, there are various opinions about that. A slight majority, at least, will tell you that these filters do help some. They're not the solution, the magic cure for light pollution, but my experience has been that it does help a little bit. Any help that you can get in the battle against light pollution is worth trying. Now, these filters cost anywhere from $20 or $30 at the low end, all the way up to hundreds of dollars for some of these very sophisticated narrowband filters. So there's that to consider as well. But I recommend that you at least get an inexpensive broadband filter and just see if it does any good for you. And if so, then that will help you in dealing with light pollution. So I'm sure you can think of other ways to deal with light pollution. Here's a thought. This telescope, my 8-inch Schmidt-Cassegrainian telescope, has a focal ratio of f10, which makes it a slow telescope. Now, I'm not going to get into any real technical details here, except to say that an f10 telescope doesn't collect as much light per unit of time as a telescope with a shorter focal ratio does. And therefore, this one is not as good, especially if you're imaging, or if you're imaging, you're trying to take long exposure photographs. This telescope will limit the amount of the time of your exposures because it just doesn't collect enough light per unit of time to give you a good image before the field rotation, star trailing starts to appear in your photograph. So not particularly good for deep sky objects and light polluted skies if you're trying to photograph things in the night skies. Now, you'd be better off to use a telescope that has a focal ratio of 6 or 5 or even better. That will give you a wider field of view. You can collect more light, and that will help out in light polluted skies. Fortunately, with this one, I can use a device known as a focal reducer, which basically converts it from an f10 scope to an f6.7 scope. Wider field of view, much better light gathering capability, much better for certainly taking pictures in the night sky, even in light polluted skies. So if you have a telescope that's slow, if it's got a long focal ratio, f8, f10, something like that, you might do some research and find out if there's a focal reducer available for your telescope that can make it a faster telescope and therefore better to use in general for deep sky objects and in light polluted skies specifically. So there is that. So let me just kind of summarize what I've said here by saying this. When I go out to view or image the moon, I don't worry about light pollution. It's bright enough, I'm going to be able to see it fine. If I'm going to image or view the brighter planets, Venus, Jupiter, Saturn, I don't worry too much about light pollution. They're bright enough, I'm going to be able to see them. But when I start trying to view these deep sky objects, nebulae, galaxies, star clusters, very dim, very faint, and tend to be washed out by light pollution, impossible to see a lot of times because of light pollution, and they may even appear in an 8-inch telescope, the fainter ones, as nothing more than just sort of grayish, nebulous patches without any definition or resolution of stars or anything. So when I go out to view deep sky objects, here's what I'm going to equip myself with. I'm first of all going to get out there and try to establish good night vision. I'm going to let my eyes adapt to the darkness, and I'm going to try to maintain that good night vision. I'm going to have my red lights with me, so if I need a light while I'm out there, I can use the red light rather than white light. I'm going to try to find a place. I'm going to determine what it is that I'm going to try to view or image, and I'm going to try to get to a place where I can block off as much localized light pollution as I can while still maintaining a direct line of sight to whatever object that I'm trying to observe. I'm going to make sure that my dew shield is in place on my telescope. This is always on my telescope when I'm trying to view deep sky objects, even if there's no threat of dew. I'm going to put something over my head, my eyepiece, my camera, or whatever to help block out any stray localized light pollution that might try to get in there and affect my eyes or my optics, even if it's just a dark t-shirt. And I'm going to make sure that I've got my light pollution filter screwed into my eyepiece. I'm also going to make sure, if I'm using this telescope, that I've got my focal reducer in place, which widens the field of view and enables me to collect more light faster. So those are the weapons that I'm going to use to equip myself to try to at least make a little headway in the battle against light pollution. Those things are not going to eliminate light pollution. It's not going to magically give me dark skies, but anything that you can do to lessen the impact of light pollution will make for a better viewing or imaging experience. So that's light pollution. What it is, why it's a problem, those are some suggestions, some practical suggestions of things that you can do to mitigate it and deal with it as best you can. So we'll call it quits there for this video. If you have learned anything from this that's valuable to you, if it's been worth it to you watching this video, perhaps you might consider liking the video. And if you would like to watch other videos on this channel or keep up with the channel and it's being of some benefit to you, perhaps you might even consider subscribing to the channel. And if you would, I would appreciate that very much. So let's close for there. Let me close as always by thanking you so very much for dropping by and watching. And I wish all of you clear skies and good viewing.